Hey guys, so in preparation for our semester exam, this is going to be a review for everything we did in Unit 6, which was sequences and series. So sequences are actually super easy. It's an Algebra 1 TEK, so it's something that should be familiar. The first kind of sequence that we talked about was an arithmetic sequence. So arithmetic sequences are the ones that have the pattern where either they are adding or they are subtracting. There's two different ways to represent these sequences. There's the recursive rule here on the left side, where you always have to state what the first number was. So A1 is a certain number. And then after that, every single other term can be found by knowing the previous term and adding the common difference. So that D, common difference, that represents the pattern. For explicit rule, this is the one that you would use if they asked you to find like the 100th term or the 98th term. You have to know the first term here, and then common difference again, and then n minus 1, and you would simplify that formula as much as you can. Okay, so let's look at some examples here. Write the recursive and explicit rules for the sequence. So this one on the left, from 9 to 2, it's definitely getting smaller, so it's subtracting 7. And then just make sure that that pattern holds the entire time. 2 minus 7 would give me -5, and then minus 7 again would give me -12. So here, D is -7. So for our recursive rule, you start off by stating the first term, which in this one was 9, and then A sub n equals A sub n minus 1, and then the pattern was that you subtract 7 every single time. So that right there is the recursive rule. Okay, for explicit rule, let me scoot this up a little. So there's our pattern there on the right. We're going to follow this. So A sub n equals, again, you have to say what the first number was, so 9, plus D, so it would be -7, parentheses, n minus 1. Then let's simplify this as much as we can. So we're going to distribute that -7. So this becomes 9 minus 7n plus 7. And then combine your like terms. So A sub n equals 16 minus 7n. So that is our explicit rule. Okay, so let's do another example. The one right next to it. So from 1 to 5, it's getting bigger, so they're definitely adding. Looks like 4. 5 plus 4 gives me 9. 9 plus 4 gives me 13. So our common difference here is +4. For our recursive rule, again, always start by saying what the first number was. So A sub 1 is 1. And then for A sub n, if you know the previous term, so A sub n minus 1, all you have to do is add 4, and that's how you can find each number in this sequence. But for our explicit, A sub n equals 1 plus 4, parentheses, n minus 1. So we're going to distribute that 4. Be 1 plus 4n minus 4, then combine our like terms. So 1 minus 4 is -3 plus 4n, and that is our explicit rule. Okay, the other kind of sequence that we talked about was a geometric sequence. So this one, the pattern is going to be either multiplying or dividing. So recursive rule is really similar. The only difference is that they are multiplying by a common ratio. So this is the pattern in your sequence. And then explicit rule turns into exponential. So we get our common ratio and we raise it up to an exponent. So again, we're finding recursive and explicit rules for each sequence here. So here, from 2 to 6, it's getting bigger. And I know you could say +4, but that wouldn't hold for the entire sequence. So think of multiplying. 2 times 3 would give me 6. 6 times 3 gives me 18, and so on. So our common ratio here is 3. So for our recursive rule, always state the first number. So a sub 1 was 2. And then for a sub n, our common ratio is 3, and we would multiply that by the previous term. Okay, and then for explicit, this time you don't really need to simplify anything, just follow the pattern. A sub n equals a sub 1, which was 2, times our common ratio was 3, raised up to the n minus 1 power. That's it, nothing to simplify. Okay, let's look at the one next to this one. So from 84 to 42, it's getting smaller, so it's dividing by something. Looks like it's exactly half. So instead of saying dividing by 2, I'm going to say multiply by 1/2. And just make sure that that pattern holds the whole time, which it looks like it does. So our common ratio here is 1/2. Recursive rule, a sub 1 was 84, so that's our starting off point. And then for a sub n, just take half of the previous term. So there's our recursive rule. And then for explicit, a sub n equals 84 times 1/2 to the n minus 1. So when r is a fraction or a negative number, you'll see it in parentheses like that. Okay, so that's like really basics of the two types of sequences that we talked about. The other thing with these sequences is you need to know how to find some of these missing terms. So arithmetic and geometric means. Number 5, find 4 arithmetic means between 9 and 29. So 4 arithmetic means between those two numbers. So arithmetic means that it's either going to be adding or subtracting, so we'll figure that out in a little bit. But there is some sequence out in the world that starts with 9, then there's 4 numbers, and then it's 29. So they want us to figure out what 4 numbers go in that blank. So you're going to use the explicit formula of this sequence, which is a sub n equals a sub 1 plus d n minus 1. So we're going to use that formula to figure out what d is. So figure out the pattern, and then we can fill in the blanks. But that would mean that I know everything else, which I do. So the first number is always a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. So for that a sub n, we're going to use a sub 6, meaning that n is 6. So I'm going to plug in 29 here. 9. We don't know d yet, but we do know that n is 6 minus 1. Okay, so let's simplify and solve for d. Subtract 9 from both sides. Divide by 5, so d equals 4. So that's the pattern. If I go back to my list up here, 9 plus 4 would give me 13. Plus 4 again is 17. Plus 4 again is 21. Plus 4 again is 25. Plus 4 again gives me the 29. So these 4 numbers right here are what goes in these blanks. Okay, our next one. Find 2 geometric means between -3 and 192. So same premise. So there is some sequence out there that starts with -3, then there's 2 numbers, and then it ends with 192. So we want to figure out what goes in those 2 blanks. Because this is geometric, they're going to be multiplying by something or dividing, but that's the same as multiplying by a fraction. Okay, so same thing. What pattern would I follow? So the explicit rule for geometric is a sub n equals a sub 1 times r to the n minus 1 power. We're going to fill in everything that we know. So -3 is a sub 1. 192 is a sub 4, which means that n would be 4. So we're going to plug all that in. 192 equals negative 3 times r to the 4 minus 1. Well, 4 minus 1 is 3. Then if I divide by negative 3 on both sides, that's negative 64. And then we're going to cube root both sides. And that gives me negative 4. So r is negative 4. So this is geometric, means that they're multiplying by negative 4 the entire time. So starting with that negative 3, if I multiply that by negative 4, that gives me positive 12. Positive 12. And then if I multiply by negative 4, that gives me negative 48. And then if I multiply that by negative 4, that gives me positive 192, which is where I'm supposed to end up. So these two numbers here are what go in those blanks. Let me erase that comma. I only needed those two numbers. Okay, so those are my answers. Okay, so all of this was sequences, just a list of numbers. The next thing that we're going to do is series. So a series is not just a list, it's a sum. They are going through and they are adding the numbers as they go. So these lists can really go on forever, so you can't really add the entire list, but you can add partials, so that's why it's partial sum. Each kind of series has its own formula. So for arithmetic, we're going to follow this one. For geometric, we're going to follow this one. And just remember that if it's an arithmetic series, it's going to look like a linear equation. And if it's geometric, it's going to be exponential. That's how you tell the difference. Okay, so number 7, find the indicated sums. So when I look at this right here, 6k plus 1, that's a linear equation. It's like mx plus b. So I know that this has to be arithmetic. Okay, so that means I'm using this formula here. We need to know n. So n is 10 here. It's always going to be the number up here on the top. I need to know a sub 1. So to find a sub 1, use that formula and plug in 1 where the k is at. So that gives me 7. And I need to know a sub n. But if n is 10, I need to know a sub 10. So plug in 10 to that formula, and that gives me 61. So now I have everything I need to go in the formula. We can plug these numbers in. So s sub 10 equals 10 times 7 plus 61 divided by 2. And we're just going to put that whole thing into the calculator. And I get 340. Okay, let's look at the one next to it. So this time when I look at this formula, this is exponential. See how it's an exponent? So this one has to be geometric, which means that I'm following this formula here. So I need to know n for this exponent here. N is 7. I need to know a sub 1. So that just means that if I were to plug in a 1 into that formula, what would we get? 1 minus 1 is 0, so this would just be 3. And then I need r. So r is our common ratio. When you look at this, common ratio is going to be whatever is being raised up to the exponent. So common ratio is -4. Okay, so we have everything we need. Let's just plug it into that formula. So s sub 7 equals 3 parentheses 1 minus negative 4 raised up to the 7th power over 1 minus negative 4. So we know that minus negative is going to turn to a plus, so you can go ahead and change those and then just type it into the calculator. You could even leave it as minus negative. The calculator is smart enough to fix that for you. Okay, and I get 9,831. So that's the thing about exponentials. You're going to get some big numbers like that. Okay, the bottom two are still the same formula. It's a word problem, so you're going to have to figure out what everything represents. The Jefferson Theater contains 33 rows. If the first row has 12 seats, and each successive row has 4 more seats than the previous row, determine the number of seats in the theater. So what I'm noticing on this one is how it says 4 more. So anytime you see more, that means that they're adding, which means that this is going to be arithmetic. 33 rows, that is our n. The first row has 12 seats, so that's the first row. That has to be a sub 1. And then 4 more, that's the pattern, so that's D, our common difference. They want us to determine the number of seats in the theater, so the total, add up every single number in this sequence. So we are going to follow this formula here. We need to make sure we have everything. So we have n, that was the 33 rows. We have a sub 1. It had 12 seats, but we don't have a sub n. We would need to know how many seats are in the 33rd row. So we have to first start off by writing an explicit formula to represent this. So a sub n is always a sub 1 plus d, so plus 4, n minus 1. Now, we're trying to figure out how many seats are in the 33rd row. I totally messed this up. This should be a 12 because that's the first row. Okay, so we're trying to figure out how many seats are in the 33rd row. So what we're going to do is we're going to plug in 33 where that n is at and see what we get. And I get 140. So that very last row has 140 seats. Now we can do the partial sum formula. So it's n times first row plus last row divided by 2. So this is going to go into the calculator. And I get 2,508. So there are 2,508 seats in the theater. Okay, the one right next to this. The grocery store started raising money. In their first month, they raised, $4,000. Each month after, they raised 1.5% more than the previous month. Find the total money raised after 4 years. Okay, so it's a percent. So that means that this is going to be exponential, which means that this is a geometric sequence. This right here at the top says first month. So that has to be a sub 1 there. 1.5 is our common ratio. Just be careful to change it into a decimal and not a percent like this. So we're going to use 0.015. And then n is the 4 years. But again, you have to be careful. They're talking about months, and then nowhere they change it to years. So n is going to be 48 months. Okay, so we're going to use the geometric formula. So we know the first month was 4,000. We know the rate was that 1.5%. We know that n is 48 months, so we have everything that we need. Let's just plug it in. So S sub 48 equals 4,000. 1 minus 0.015 raised up to the 48 over 1 minus 0.015. And that will give us our answer. Let me type this into the calculator. Okay, so I get here 4,060, and we're talking about money here, so I'm going to use 2 decimal places, and 91 cents. $4,060.91. That's how much they raised. Okay, the next thing that was in this unit was Pascal's Triangle. So it has this cool pattern where it starts up with 1. So this kind of triangle of 1s at the top. But then after that, every single element is the sum of the diagonal. So like 2 is 1 plus 1. If I were to pick one down here, the 10, that's the sum of 4 plus 6. This here, the sum of 10 plus 5, 15. So you can continue this pattern pretty much indefinitely, forever and ever and ever. So this is useful in binomial expansions. If you're less than 6, it's going to be easily findable. You can Google it and find an image. But if it's more than that, you're going to have to find the element yourself by using a combination formula, this right here, where n is the row. So see how the rows are numbered? And r is the element. The one thing to be careful of is they start counting at 0. So this is the 0th row, the first row, second row, third row. So find each element in Pascal's triangle. So they want the 6th element in the 3rd row. So element is r. So this means that r is 6. And row is n. So n is 3. We're going to plug it in to this formula here. So C 36 is equal to 3 factorial over 6 factorial (3 minus 6 factorial). I kind of don't think this makes sense. I think it should be the other way around. Sorry guys, I'm noticing mistakes as we go. I think it should be the 6th row, 3rd element. Because if you look, we already have our 6th row. So we technically already know the answer should be 20. Let's see if we get that. So yeah, this was supposed to be the other way. So n is 6, r is 3. So up top is going to be 6 factorial over 3 factorial 6 minus 3 factorial. And then now you can type this in. Your calculator does have those exclamation marks built in, so you should see a button that has that. And I'm typing it in. And sure enough, yes, I get 20. Okay, so then this one, number 12, this one I think is correct. It wants the 13th row. So in our picture, we only have 6 rows, so it's going to be somewhere way down here. So element is r, row is n. So we need to find the combination of 13, 5. So 13 factorial over 5 factorial 13 minus 5 factorial. So again, you just have to type all of this in. So I get 1,287. Okay, the binomial theorem. So the r plus 1th term in the binomial expansion of a plus b to the n power is defined as, so finding that combination, then the first term, so that a, you raise it up to the n minus r power, and then the second term b, you raise it up to the r power. So it says find the indicated term of each binomial expansion. So a plus b to the 10th power, that means that you would have a plus b times another a plus b times another a plus b. So you would have to do multiplication 10 times, and they want you to find the 8th term in your final answer. So instead of having to do all that work the long way, use this shortcut that it has right here. So I know it says the 8th term, but see how it says r plus 1? So technically that 8 is r plus 1, which means that r is 7. And then for n, that'll just be whatever they're raising it up to, so that's 10. Okay, so our formula is the combination 10, 7 times a to the 10 minus 7 and times b to the 7. So this right here actually becomes a number. You would use this formula that we have with the factorial, but it's even easier than that. Your calculator actually has a combination button. It might look like this with the C parentheses. It also might look like, I think I wrote it up here. No, I didn't. It might look like this, where it's like capital C and the NR is on the sides. So it is a calculator button. So I'm going to cheat and use that. 10, 7. And that's 120. Times A to the 10 minus 7 is 3. And then B7. That's already the answer. That's going to be the 8th term in your final expansion. But it's easier when it's just letters like that. It's just A and B. This next one is going to have numbers, so it's going to get a little bit more difficult. So again, the 3rd term, that's r plus 1. So that means that r is 2. And then n is whatever exponent they're raising up to, so they're raising up to the 12th power. Now here, you know how we're using this pattern A and B? Well, A is going to be x. B is negative 7 because of the minus. So now we're just going to follow the pattern that it says to do. Combination 12, 2 times x raised up to the 12 minus 2 power times negative 7 raised up to the 2nd power. So combination 12, 2, put that in my calculator, I get 66. Then 12 minus 2 is 10. And then negative 7 raised up to the 2nd power, that's also a number, that's positive 49. So these are like terms that we can combine and put together. Everything is being multiplied here, so we're going to multiply those numbers, 66 times 49. And that gives me 3,234. And you still have x to the 10. So that would be the 3rd term in that expansion. Okay, and this was the whole unit. On the exam, we're only going to have about 4 questions over this unit, but it could be anything over what I covered right now in this video.